John always has an imaginary girlfriend called Jane, whom no one sees. What if John found a link between his imaginary girlfriend and mathematics? You guessed it, it's a complex number, with John as the real part and Jane as the imaginary part. Now, let's focus. Have you ever tried punching the square root of -1 and gotten an undefined result on your calculator? It means you to have an imaginary girlfriend. Haha. In this lesson, we are going to talk about the imaginary friends of mathematics, that is, I, and how math plus I makes a complex number. Are you ready? Let's go.
That is a plus bi, a being the real part and bi being the imaginary part. Okay, let's get into computation of complex number. We have I, the complex number, that is square root of -1. Punching on the calculator is undefined, and I square is equal to -1. I cube is I square times I to the power 4 is I square times I square, that is equal to 1. Let's move to computation, addition, subtraction, and multiplication, division. Moving to addition of complex number, we have 5 minus 2i plus 7 plus 3i. Adding this, we are going to add the real and the imaginary part. 5 plus 7, we are going to have 12. And minus 2 plus 3, we are going to have I. Having more complicated one, we have root 2 and this. Adding the real part, we are going to have what? This is the real part. Adding a real and a real, we're going to have what? That is 8 root 2. And adding the imaginary part and the imaginary part, we are going to have what? 6i. Moving to subtraction of complex number, we do as addition of a subtraction of the imaginary of the real part and subtraction of the imaginary part. The real and the real will give what? We subtract 6 minus 3, we have negative. You have 3, and you have -2 plus 3i, that is minus that is minus 7i. Okay, moving to a complicated one, we have this one. Subtracting this, we have -2 minus root 3, and subtracting 5 minus 6, we have 2i. That's amazing. Moving to multiplication of complex number. If you have a multiplication of complex number, it's just like the number, the symbol of multiplication. We do this times this. On the other side, we do this times this. Okay, doing that, we are going to be having 6 times that 18, 6 times I, that is 6i, -2i times 3, that is -6i, and you have -2i times I, that is -2i squared. And from the beginning, we know that I squared is equal to -1, and -1 will be positive. That is why you have a 2. And at the end, we're going to have 20 as the answer. Okay, doing a complicated one like this one, we have root 2 times root 2 is 2. 5 times that is 5 times 2. And we multiply the other side, we have 3i root 2. And 5 times that, we have 25i root 2. And we have on the other side, 5 times 3, we have what? 15i squared. And I squared is -1, we are going to have -15. Computing this, we are going to have, using this, we are going to have -5 plus 28i root 2. That is the answer. In the case of division, we have division of complex numbers. We can have like this, or we can have any other type of division. Let's take this condition, 1/2 plus 2i. How can we solve this? The thing we're going to do is to rationalize the denominator. And to rationalize the denominator, we're going to introduce the conjugate. And the conjugate of this is like real plus imaginary. The conjugate of this is real minus imaginary. That is the conjugate of what we have up here. And that's exactly what we did here. And we're going to have 2 minus 2i. And computing this, we're going to carry multiplication and have 2 minus 2i. And the denominator, since it's a conjugate, you just have to multiply this and this and this and this, since this other part will cancel out. And you have 4 plus 4, that is 8. Why do you have 4 plus 4? Because 2 times this, that is -4i squared. And I squared is -1. Then you have 4. And that is the answer. And you're going to compute to have 1 all over 4 minus 1 all over 4i. That is the final answer. Having the division 1 over I cube, first thing we're going to do is to simplify I cube. I cube is I squared times I. There is -i. Proceeding, we're going to have what we do. The rationalization and the conjugate of it is I and I. I up and I down. I squared is -1. Okay. Negative that is 1. And for our answer will be I. Okay. Proceeding to polar form of a complex number. The polar form of a complex number is represented as what? Z is equal to R cos theta plus I sin theta, where R is the magnitude of Z and theta is the tan inverse of imaginary all over real. Moving on, the example you have R, that is A plus IB. The imaginary will be, that will be, theta will be equal to tan inverse of what? B all over A. Hope you're understanding this, and if you like it, just subscribe and share this video. Let's proceed to another part of an example, that is this one. As earlier we simplified to have 1/4 minus 1/4 I, And proceeding from here, we have to find r, that is 1/4 square plus 1/4 square, because squaring a negative, you have a positive. And you have this, furthermore, simplifying this, we are going to have that. And in tan theta, you have theta is equal to tan inverse of negative 1/4 all over 1/4, that is tan inverse of negative 1. And tan inverse of negative 1 is negative pi on 4. I hope you know about that. Okay, and our r is root 2 on 4. Okay, simplifying this, we are going to have root 2 on 4. Therefore, we substitute back in this initial equation, just substituting r and theta, we have root 2 cos negative that plus I sine negative that. Since cos theta is even and sine theta is odd, we're going to be having what? Cos pi on 4 minus I sine pi on 4. Hope you know about even and odd function. If you don't know about, I'll drop a video up here to explain better. Then move on. We have solved for z in z squared plus z plus 1. We're going to use the quadratic equation formula, that is z is equal to negative b plus minus b squared minus 4 is over 2a. That implies that z is equal to what? Minus 1 plus minus 1 square minus 4. Just substituting a and b. Here is a, here is b, and here is c. And you have this as the answer. Okay, we can further simplify this. You have what? Z is equal to minus 1 plus minus square root of minus 3 all over 2. And minus 3 is equal to what? Root 3 times root of negative 1, that is root 3 dot I. That is our answer, root 3 dot I, and you simplify half root 3 dot I, and this is the final answer for z. Therefore, z is the positive and the negative part. Okay, solving for this other question, z squared is equal to plus minus 1. What you can just do is you bring a negative 1 on the other side, and you do the square root on both sides. That will be square root of negative 1, and we're going to be having plus minus 1, plus minus I, normally. Okay, but if they ask for the magnitude, you are going to be having z is equals to I. Taking into consideration, that is the magnitude. That is where we have I. Okay, proceeding to the next question. Find the imaginary of I plus 1 all to the power 8z squared. What is about imaginary? Example, you have z is equal to a plus ib. If they said find the imaginary of z, that is imaginary of z, the answer will be b. And in other case, if they say real of z, your answer will be equals to a. Hope you know about that. Take that into consideration because that will be very crucial in this topic. Moving on, find the imaginary of this. We're going to solve it gently, taking step by step. We take first of all I plus 1 and simplify it using the polar formula. We are going to have r, that is 1 square plus 1 square, that is root 2, and we are going to have that. And to find theta, that is tan inverse of what? 1, tan inverse of 1, that is equal to pi on 4. And that is why you substitute it here and have the answer. Okay, substituting the polar formula, that is r cos theta plus I sine theta. Okay, that is what we have. I substitute back here. And here's the answer. Using you know about Demoivre theorem? I think you know about it. I guess you know about Demoivre theorem. When you have I plus 1 all to the power 8, you have to substitute it back. That is Demoivre theorem state if you have r to the n, okay, z to the power n is equal to r to the n cos n theta plus I sine n theta. That is Demoivre theorem. I want to explain it in the next video out here. Let's proceed with this and have this as the answer. Okay, because using the Demoivre theorem, we are just going to substitute 8 here. Z to the power root 2 to the power 8, b2 to the power 4, and we have this as the answer. Okay, further simplifying this, cos 2 pi is 1 and sine 2 pi is 0. Therefore, we are going to have 16 as the answer. Okay, and our z, because here we have z squared, therefore z squared is x squared plus 2xyi minus y squared. How do you know about that? Because we are going to have I, y is I square, y square, and I square is negative 1. That is why you see a negative at this point. Substituting it back to the initial equation, we are going to be having 16. Okay, because there is a 16, this one, times x times z squared, that is x plus that square. And since you asked for to find the imaginary part, we are going to separate the equation into two, real and imaginary. And at the end, the imaginary part will be what? The 2xy, and we come to the end of this part. Moving on to the next question, that is solve for z to the power, for z in the equation, z to the power 4 plus 16. What you can do is to bring z on the other side and move 0 away. Expressing in exponential form, from a polar form, you can transform it to an exponential form. Example, you have r cos theta plus I sine theta. Okay, to an exponential form, you are going to have what? R e to the I theta. Okay, can you just figure out what happened here? Here, I think because z is equals to minus 16, r will be equals to 16 because square of 16, that is square root of 16 square minus 0 square, that will be 16 at the end. You have r this and you have theta. To find theta, that is tan inverse of 0, and tan inverse of 0 is pi, that is 180 degree, and you have pi here. Okay, since you have to find 4 root and here you have just 1 root, you can use a trick. If you have theta as this, and if you add 2 pi to this theta, will this not be the same? Because cos of theta is equal to what? Cos of theta plus 2 pi. Yeah, that's a trick in mathematics that you might not have known, but today I think you know about it. Let's move on. Okay, substitute here. You can add 2k pi since you have to find different root, and k can be from 0 to 3 since you have 4 root, like 0, 1, 2, 3. Okay, let's proceed. You have this, and you do the square root at every point. The square root of that, you're going to have 2e I to the pi on 4 plus 2 pi on 4. I know a guy just asking me where is pi on 4 coming from. Yeah, I'm like guessing with you because we have 2 and you have tan inverse of that. You come back to it. That is from polar coordinate. Okay, you have this as the answer. Proceeding with this, you have this as the answer. Then our k is from 0 to 3. Okay, we can find the value of z from here, and z is equal to 1. When that is 0, you have this as the answer. When it's 1, when it's 2, and when it's 3, and you have that as the final answer. Finding an expression for sin 3 theta in terms of sin theta and cos theta. That is really amazing. How can we do that? That is a question we're going to ask. We're still going to use Demoivre theorem, and Demoivre theorem states that cos theta plus I sin theta all that cube is equal to cos 3 theta plus I sin 3 theta. Oh, that's amazing. From here, we can proceed saying that we are finding what? The imaginary part, because sin 3 theta is at the imaginary section having an I. Therefore, we are going to be having sin 3 theta is equal to the imaginary part of all of this. And the imaginary part of it, we are going to solve by expanding cos theta plus I sin theta cube. Okay, and having that, we are going to expand taking this and this. That will be cos theta plus I sin theta times that square. And you have this. For the simplifying, we're going to move on and combine the imaginary and the real part. We combine and have this. Okay, we see. For the simplify, we have this. And at the end, we're going to have sin theta is equal to 3 cos square theta sin theta minus sin cube theta. Since we took c equals to cos theta and s sin theta. And our sin 3 theta is equal to this part, that is 3 cos square theta sin theta minus sin cube theta. How was this video? You found it interesting? If yes, drop in a comment. If no, drop in the comment because I want to know if I'm good or if I'm learning something. See you in our next video.